Hello and welcome to your next tutorial in Visual Basic, and in this tutorial we're going to cover a bit on data type conversion, and just because this video wouldn't be long enough because it's not that material, I'll just show you some neat tricks for formatting your numbers, which isn't much, so this should be a quickie. So let's start with data type conversion, since that's the base of this video. And well, we've actually done conversion explicitly, and I never really told you, so I'll show you that example again. So I'll just declare a variable here, and later what we've done is we take that variable and set it equal to something like this. We'd use the keyword such as CSNG, and then inside the parentheses we would type in something like text box, whatever the user might type in. Now, as you can see, this variable is not being converted as it's already a single, but it's converting whatever the user typed in into whatever data type you need it in order to correspond with the data type of the variable. So this variable is a single, so we want to convert this into a single. Not to say that you couldn't make this, a double or a decimal. You could, you can even go integer if you want, but we still have to convert this from how the program will be reading it inside the text field into an actual number. So that this is called implicit or explicit data type, and that's basically the going back and forth. So we have implicit, make sure I spell all these right, explicit conversion. And basically that's the use of using things such as these. So there's way too many. I won't be able to put all of them out there, but you get it, right? It's just these guys right here. So I'll get rid of this, and I'll actually keep that up there. And another type of conversion is something that the compiler or the application will do by itself if it needs to and if it can. If it can't, it'll crash, and we don't want that to happen. And that's why we have this try catch, just to make sure if any errors happen, it can stop it. Not that it can stop all errors. I just want to throw that out there. There's plenty of errors that try catch can't keep from happening, but we don't have to worry about that now. We'll learn that with exception handling further down the road. So the next type of conversion is narrowing conversion, and that's basically if maybe you have a decimal number, a number with a decimal, or it's a fraction, and it's being assigned to an integer. So for an example, you can type in, let's actually set this equal to something, or you know what, let's change this to an integer, and let's have a equal to c single, and then whatever we type in. Then on the label output, let's see here, we want to print a. So as you can see, it's going to convert whatever we have to a single, but a is an integer. So what will happen if we make it a decimal? Well, let's find out. So let's run this. So if I type in, I have to make sure I typed everything right. If I type in 13.8, what happens? Well, we got 14. Now this is actually different than what we've seen before. When you're working with integers, just integers, it will always take that first number, but as you can see here, it actually rounded for us. When we go from a single or any kind of decimal data type to any kind of integer data type, it will round it for us. So if we go 13.4, now we get 13. So that's really nice. So there we go. That's narrowing conversion, and that's basically shortening it. And the last data type conversion I want to show you is both the val function, which is short for value, and the string function. So let's start with the, you know what, let's go with the string first. You know what, no, let's keep it like that. No, yeah, I want to go with the string first. So I'll set this as equal to a string, and So whatever you type in here will be a string as such. And then down here, I would like, what do I want to do? You know what, I'll have to create a new variable called dim equals a underscore conv, as we'll have to make that a single. And then down here, a underscore conv will be equal to, and then what we have to type out is val, the function, and then inside there we put in whatever number we want to convert. So we throw in an A. Now if you remember from the last tutorial, if we just set a string equal to a number, you will end up getting another number plus 48. You're going to get another number because whatever a number the value is as a string does not coincide with a string. So we're going to have to make it a number, and that's using the val. And basically you can put any kind of string in here. Whoops, I don't know. There you go. And it will convert it into a number for us. And then our output, we'll want to make that conv. So at first you won't quite see any changes because it should just come out as the number. So if I type in 133, we get 133. So I can't really prove to you it worked, but it is. It's changing it for us. Actually, allow me to just change this into a string. I don't know. 100 sheep jumped over the moon. I hope I spelled everything right. I click save, and oh wait a minute, I want to change that now. Oh wait, no, it won't, because whatever I type in, it will just I can just type in 0. It won't matter. I click calculate, and now 100 appears there. And the reason is because it keeps doing this until it no longer finds a string, a character that can be converted into a number. As the rest of these are actual letters, it'll know which one is a number and which one's not. So if I threw in like the number 33 right here, and then saved, and then tried this again, now just put 0. It's still 100. It never caught the 33 because as soon as it went into this white space right here, it was saying, hey, this is not a number, so I'm cutting it here, so it does not continue. Now the other one I want to show you, so I'm going to now have to make this a single and make this a string, and I want to make this a single right here. So a conv, in order to convert a number into a string, what you'll want to do is use the, let's see here, the string, str. So there you go. So now we use the string. It's pretty simple. I didn't quite show this one to you in that string video tutorial. I think that was the last one, but because I didn't want to do conversions yet. But here it is. So we can type in a right here. So a conv string a, so it's whatever you type in, single, changing it to a string, and it will print that. Okay, so let's do this. So if I type in, let's say, I don't know, 67, well, there it is. So it worked, even though, again, I can't really show you. But now I'm actually going to show you the difference between a number that's a string and a number that's a number through concatenation. Yep. So I'm going to create another variable up here, dim b as single, and I'll throw in total right here. So now I'm going to get rid of this and make this b is equal to c single text input 2 dot text, and then we'll have total is equal to a plus b, and I'll click save, and then label output will be total dot to string. There it is. I'll click save, and hoping I got everything correct. I'll probably want total to be single as well. Okay, I think I have everything correct. So this should be proper math. Whoops. There it is. So it's proper math. It adds them together. However, if these are both strings, string string, and I want this to be, whoops, string right there, and I want that to be a string as well, and I want the final to be a string as well. So if we do this, let's see what happens if we type in 5 and 6. Now we get 56. Well, why is that? 5 plus 6 is 11. This can't be right. Well, the reason is because since now that they're strings and not read as numbers, it's now concatenating them instead of adding them together. So it's just putting them side by side. So this is why. Now another problem might be, well, what if one of them is a number like this, single, so I'll change this to a single. What will happen there? What if I make this, I'll just keep that as a string. What will happen this time around? 5 plus 6 is 11. Well, now it worked. Well, that is because the first one, in Visual Basic's a little different. Since the first one was being read as a number, it automatically assumed that the second one was a number as well. So it's going, you know what? Let's convert these. So that's what it did for us. So as long as you have one as a number, you should be pretty much all right. However, the reason why I showed this to you is to make sure that each one is make sure each one's properly defined. So I'll want to throw in narrowing conversion. So yeah, don't try what I just did. You don't ever want to do that. That's no good. So narrowing conversion is, I'll just throw in an example, decimal to integer, and the last one I showed you was the val, which is string to integer, and then the other one was string, which led to int to string. So that's how you can do that. Now the last thing I wanted to show you, which is some fancy formatting numbers and whatnot. So I'm going to make all these numbers. You know what? I can get rid of this now, all of these. And just show you some neat things. So you can actually change the format of how your numbers come out. And how you do this is you put some parentheses here, type in some quotes, and then you type in n, which means a standard number. So if you do this, whoops, total was not declared, my bad. Make that an A, and I'll type in something like 56, I click calculate, and I get 56.00. The reason for this is because the default number of trailing decimals is 2. So what you can do is always change it by putting a 0 or a 1 or a 4 even. So if I do that, if I type in like, whoops, I'm sorry, 107, we now have 4 trailing decimals. And you can do all sorts of things. You can do currency, so you use a C there, and C4 is a bad idea because that doesn't make sense, but I throw in 34.5, and I'll get $34.50, but of course I shouldn't have kept the 4 there. Another one is percentages. I'll just put a P. So if I go F5 and if I type in 1 whole is 100%. So it automatically does that for you. 0.23 will be your 23%, and so on. So that's really, really nice. And another one is exponents. So basically, if you have a really big number, so if I threw in, let's say, 34, 1, 2, 3, 4, 5, and I click calculate, well, now it's going to do that for us. So that's really nice. So it gives us scientific notation, basically, with a 3.4. And that's it for the formatting numbers I wanted to show you. So I hope this tutorial was useful for you. Nothing too difficult, right? This is pretty easy. And I'll see you next time.